Hello class 10, unit 10. This is the first chapter of class 12, haloalkanes and haloarenes. So today we are going to deal with a very important part that is called the dipole moment. Dipole moment is nothing but it is a measure of the two oppositely charged separation in a molecule. Two oppositely charged separation in a molecule means one of them has to be electropositive and the other bonded atom should be highly electronegative in character. It is denoted by a symbol called mu. It is given as mu equal to nothing but Q into D, where Q is nothing but charge of the two atoms, means two oppositely charged, means one has to be electropositive, other one has to be electronegative. And D is nothing but the internuclear distance between the two oppositely charged atoms within the molecule, means one has to be electropositive, other one has to be electronegative. Straight away, we have to deal with the situations. Now arrange the following in the order of descending, or this is very much important for, and they will ask about the to predict the dipole moment of this particular 4. 1, 2, 3, 4. First one is the methyl chloride, dichloromethane, trichloromethane, which is also known as the chloroform, or tetrachloromethane and methane. Now first of all, we will draw the structure, then we will go for the explanation and the diagnosis of each of the molecule. First of all, we will draw Cl, chlorine, then we will draw hydrogen, then we will draw to the hydrogen because CH3Cl, right? As we know that chlorine is highly electronegative, it tries to draw the electron toward itself from carbon. Carbon is highly electropositive as comparison to chlorine. So it will try to maximum draw out, it will pull the electron towards itself, right? But here when you compare the hydrogen and carbon, जब आप यहाँ पर carbon और hydrogen का comparison करेंगे, when you compare this one, you feel that this is highly electronegative and hydrogen is electropositive in comparison between the two. So this, the electron will shift towards carbon, and here also similar way, the electron will shift toward the carbon, the electron will shift toward the carbon. See here, one more thing. Within the molecule, we have got the vectors. These are called the vectors, and they are all showing toward the same direction. Or see, they are showing way to the same direction. To the same direction. If their vector are if they are showing in the same direction, and their value should be added up. So what happens here? The dipole moment or the net force or the dipole moment should not be equal to 0. Okay, this is the first condition. Now let me repeat. If the direction of the molecule, see the bond moment, see the bond moment here, it is showing in the same direction. See this and this and this is nearly the same direction. So all the vectors should be added up, right? So it has got the dipole moment is nothing but it should be, how much is the actual value is 1.95 dBi, right? Now we will come to the dichloromethane. It is Cl, H. You know that these two are more electronegative, so the dipole moment will shift toward the more electronegative side from electropositive. Similar way here also. But here, because of the comparison between hydrogen and carbon, the electronegativity of carbon is more than the hydrogen. So the bonding will show toward this, the electron flow will show toward this direction. Here when we see, everyone will be showing in the same direction. 1, 2, 3, more or less they are showing in the same direction, but one of them is showing to the opposite. So here the dipole moment is smaller than this one as compared. See here, 1, 2, 3, they are showing almost toward the same direction. The vectors are showing toward the same direction, but one of them is showing toward the opposite direction. So its dipole moment cannot be 0. Its dipole moment cannot be 0, but it is lesser than methyl chloride. Yes, it is 1.67 dBi, right? The third one will come it. H Cl Cl Cl. See it here. Here the electronegative of chlorine is another dipole moment is similar to this direction. I don't have to explain because we know this one, electronegative side, that dipole moment will be shifted. But here the carbon is more electronegative as comparison between the hydrogen and carbon. So what happens here, this chlorine and this chlorine are opposite to each other, hence the vector quantity is going to cancel it out. So here what happens, the dipole moment will be lesser than this one. Here the dipole moment is not going to 0, but it should have the lower, because the two of them in the opposite direction, Cl. See the bond moment or the vectors are showing in the opposite direction, and there should be dipole moment is how much is it? 1.01 debye. Okay. Now when we'll come to carbon tetrachloride, Cl, and Cl. There is a condition in the dipole moment that if the molecule are symmetrical, this one is a symmetrical molecule or not? Yes, here is chlorine bonded to carbon, chlorine bonded to carbon, chlorine bonded to carbon, chlorine bonded to carbon. These are all electronegative and they are having the same environment. All are chlorine. These are tetrahedral. All these are tetrahedral in character. But this is having the same substituent, chlorine. In that circumstance, if they are having the same substituent, always the dipole moment goes to 0. Got clear? Now we'll study about the methane. Methane also should be showing same. And here one more thing which I have forgotten. I'm extremely sorry. Here the dipole moment will be toward the electronegative side. That is the chlorine side. So this is the symbol of the dipole moment, right? And this is this one. So it is cancelling to each other. And the net dipole moment has to go to 0. Now we'll come to the methane. Methane, we all know that it is having bonded. Methane is bonded from all sides with the hydrogen, right? Now here, this hydrogen is less electronegative than carbon. So the dipole moment will be opposite to that of the carbon and chlorine. So here also same thing. Here also same thing. Here also same thing. But there's a criteria there and they will cancel it out. There's a criteria that if the atoms are of the same nature and acting in the same environment, and these are the symmetrical molecule, this is also something. There is no hydrogen, there is no chlorine, all are hydrogen, all are chlorine. So here also without any second thought, you just predict that dipole moment goes to 0. So here if you try to order them, A, B, C, and let's say this one is D, and this one is, sorry, this is small letter D, and this is E. Okay. Now when to want to so first of all, methyl chloride A. Then we have got the dichloromethane B. Okay. Then we have got a chloroform or the trichloromethane C. Now when we come to the tetrachloromethane or the methane, so they will be having the same weight. So they will having the same. Their dipole moment cannot be any value, but it should be 0. Please note this one because they are having the same environment. Same substituent are bonded to the carbon, same substituted, and had their vector quantity goes to cancel. Okay, so those who like to like my lecture, it is a very short and brief. Please try to share with your friends and all, and please copy it nicely by pausing it and share to your friends and relative. And if you have got any doubts, then you can pass in the comments also that sir, I'm not getting this particular points. So sir, can you repeat once more time? It is my humble privilege to lecture. Please try to press the bell icon and press the like button and all. Thank you.